Hello, my name is Ardi and we are going to solve problem 7.21 from Sadiku book. So the question is, in the circuit of figure 7.101, find the value R for which the steady state energy stored in the inductor will be 1 joule. Okay, we need to find out the value of this R here. Okay, and let's first calculate the current that we need to find here. How? We know that the energy stored in the inductor will be 1 joule. So, okay, the energy stored in an inductor will be 1/2 multiplied by the value of the inductance multiplied by the current that passed through it squared. Okay, we know the energy stored, so we know that is 1 and then 1/2. And we know also the value of this inductance, which is 2 Henry. And we need to know the value of I squared. That will be, I squared will be 1. 1. And that means that I is either 1 or -1. So 1 ampere or I is equal to minus. So this is not a problem because the sign is only the direction. So I will just assume the positive one, right? So we'll have to assume that we have the current is going to the right of the resistor here. Okay, now we need to analyze at steady state. At steady state, the inductor becomes short circuit. Inductor will become short at steady state. And so I will redraw this circuit so that I will have the inductor replaced with short circuit. So we will have this 60 volt here, and then we will have that 40 ohm, and then we will have that 80 ohm, and we will have this R here. So R, and we will have this 2 Henry replaced by short circuit. Okay, and we need to find out the I here. Maybe don't use purple. Let's use green instead. So we want to find out this I here. How to do that? Let's do KCL at this node here. I name this node as node A, and this one here is our ground. So the voltage here will be 0. Okay, let's do KCL at node A. KCL at node A. KCL said that the sum of the currents that goes in will equal to the sum of the currents that goes out. Okay, let's assume the current. So I want this to go to the right and this to go to down. And this current here will be 60. So let's do this. 60 minus VA divided by 40. Okay, that's good. And then the current that goes out, that will be VA divided by 80. VA divided by 80 plus this current here, but that current is 1. So I will have plus 1. We can now solve this for VA. Okay, let's multiply both sides by 80. So what can we get from here? We can get, this will cancel into 2, so we'll have 120 minus 2 VA is equal to VA plus 80. That means that I will have 40 is equal to 3 VA, or VA will equal to 40 divided by 3 volt. Okay, but we are not asked about VA, we are asked about I. But I can be obtained by a simple means, so that will be VA divided by R. So what is R? We don't know yet. We know I. So we'll have 1 here, and VA is 40 over 3. And this one will be the one that we are looking for. And so that will be our resistance value here. That will be 40 over 3, or that will be 13.33, and the unit will be ohm. And I think that's the answer of this question. So let's highlight this. Okay, that is if the I is going to the right. But you know, you have one more case, which is I is minus 1 ampere, but I will leave it to you on how to solve this with I is equal to minus 1 ampere. So hopefully this will help you to solve this problem. And I think that's all. Let me know if I made any mistakes in my calculation, and see you in the next video. Bye bye.